the must do's. You must get these right. Fine. The two taps T1 and T2 at the bottom of a water tank, either or both of which might be, so T1 and T2 may be open to empty the water tank. If T1 is open keeping T2 closed, the water tank initially full becomes empty in half an hour. T1 empties in 30 minutes. Nice. If both T1 and T2 are kept open, the water tank initially full becomes empty in 20 minutes. If T1 and T2 are open, that means two taps leak. That means the tank will get empty quicker. It gets done in 20 minutes. Then the time it takes for the water tank to become empty if T2 is open while T1 is closed, what is that equal to? Both are open, it takes 20 minutes. If T1 only is open, it takes 30 minutes. If T2 only is open, how long will it take? And so I'm going to think about what happens in 1 minute. That's my key question for this entire topic. If only T1 is kept open, in 1 minute, 1/30th of the tank will be emptied. If both are kept open, in 1 minute, 1/20th of the tank will get open. Why so? In 20 minutes, the whole tank gets cleared out. In 1 minute, 1/20 will get cleared out. So in that 1 minute, T2 alone will leak 1/20 minus 1/30. LCM is 60, 3/60 minus 2/60, just 1/60. Or T2 standalone will leak 1/60th of the tank in 1 minute. Or if T2 alone were operating, the entire tank will get emptied in 60 minutes. Done, 4 marks in the bag. Let's go to the next one. Very simple question, you must nail this. The key thing here, how many minutes it takes to fill or empty. Reframe that whole thing and say what happens in 1 minute, or what happens in 1 hour, what happens in 1 day. That should be the defining part of this kind of question. And then once you frame the question around these terms, it's a sitter, especially compared to what you guys would have otherwise learned. A class consists of 30 students. Each of them is registered for 5 courses. Each course instructor conducts an exam out of 200 marks. The average marks of all 30 students across all courses they've registered for is 80%. Nice. 2 of them apply for re-evaluation in a course if none of their marks reduce. And the average of all 30 students across all courses becomes 80.02%. The maximum possible increase in marks for either of the two students. Beautiful questions. So nice questions. 5 questions, 5 exams, 200 marks. So 5 into 200. 1000 marks is what each student can get a total number for. Each student. The 30 students, or the total maximum marks is 30 into 1000, 30,000. Of which the total of all of them is 80% of it. Right? So the total marks available in the system is 30 into 1000. If all of them had got complete full marks, the total marks of all the students put together would have been 30,000. Now the total average is only 80%, or the total is 30 into 1000 into 80% as it stands. But then 2 of them get their marks increased, and then the total goes to 80.02%. Or the total marks of everybody put together goes up by 0.02%. 0.02%. If this is a 100% number, what is 0.02%? Nothing but is 30 into 1000 into 0.02%. This is the amount by which the score has increased. This is 100%. What is 0.02%? That's a question we are asking ourselves. The 100% mark is 30 into 1000. What is 1% of this? 30 into 10. What is 0.02% of this? Multiply and find out. That is the number. That is the actual mark by which the score has increased. What is this 0.02%? It is 30 into 100 into 2 by 100 by 100. 0.02 is 2 by 100. This is percentage, so by 100. So this goes off. This 2 by 100, this goes off. 3 into 2, 6 marks. So the total marks of all the students put together has gone up by 6 marks. Why has it gone up? Because these 2 fellows have gone and said, look, give me more marks. Nobody's mark has come down. So the entire 6 marks is coming from these 2 fellows. Then the maximum possible increase in marks for either one of the 2 students. Totally it goes up by 6. It would be 5 for one guy, 1 for another guy, 4 and 2, 3 and 3. Best case scenario would be 6 and 0, where one guy gets 6 marks up, other guy doesn't get anything. So the maximum possible increase in mark for either of the two students, 6 marks. The entire increase in the total comes from one student. That guy got 6 more marks. That's the number we are looking for. Again, very doable. In a class, 60% and 68% of students passed their physics and mathematics exams respectively. Then the least percentage of students passed both their physics and mathematics exam. What is that? And so, physics and math. If totally 100% students are there, some cleared physics, some cleared mathematics. It could have so happened that 40% cleared both. Physics is totally 60% clear. Mathematics totally 68% clear. If 40% cleared both, then 20% would be here who cleared only physics, 28% would be here who cleared only mathematics. Nice, simple. Just take it, just put it as 40. 20 plus 40, 60 plus 28, 88% get accounted for. The remaining 12% is here. This means 40% clear both. The question is the least percentage. This shouldn't be 40. Can it be lower? Can it be 39? Can it be 38? Or if you imagine, can we just pull these two circles apart and make the overlap as small as possible? The smaller we make the overlap, the smaller this will become. Because these two balloons or these two circles, these two things push out. We'll squeeze out this. The best case scenario is when this goes to 0. I'm done. So how do I compute this? I'll say, hey, this is interesting. This is physics, this is math. This number, let's say, is x. This will be 60 minus x. This is 68 minus x. This is 0. Total should be 100. So this is 60 minus x plus x plus 68 minus x. This is 128 minus x. This is 100, or x should be 28, or the least percentage that should be there is 28%. We can use this saying P union M should be 100%. P intersection M, what should it be, and do the formulaic way of doing it, or we can do the diagrammatic Venn diagram visual way of doing it. Both ways you can find out those 28%. If you have some practice in this topic, you're looking at this question and writing the answer in half a minute. But even if you don't know the funda and the formula, you can figure it out, not rocket science. Set theory is a very simple topic. Wonderful. I'm going to go to the next question. Log to the base 2 of log to the base 3 of log to the base 4 of A equals log to the base 3 of log to the big story is equal to 0. Then the value of A plus B plus C. First of all, rules. If log P to the base Q is R, then Q power R is equal to P. This is a rule. This is a rule of logarithm. What I'm going to do, I'm just going to plug that rule in here. I'm going to take the first one. Log to the base 2 of log to the base 3 of log to the base 4 of A equal to 0. Or this part should be 2 power 0. 2 power 0 is 1. Or this part, log to the base 3 of log to the base 4 of A should be 1. Or log to the base 4 of A should be 3 power 1, which is 3. Or A should be 4 power 3, which is 64. We're going to do the exact same method for this and this. I should be through. This thing, I'm going to have a crack at this. I'm going to erase this whole thing. Log to the base 3 of log to the base 4 of log to the base B is equal to 0. Or if I take this alone, log to the base 4 of log to the base 2 of B is 3 power 0, which is 1. Or log B to the base 2 is 4. Or B is 2 power 4, which is 16. We found out A to be 64. We found out B to be 16. Let's attack C now. Log to the base 4 of this thing is 0. Or log to the base 2 of log C to the base 3 is 1. Or log C to the base 3 is 2 power 1, which is 2. Or C is 3 square, which is 9. C is 9. 64 plus 16 is 80. 80 plus 9 is 89. Yes, that is there in the choices. We are done. Right? Nice and simple. So just use the logarithm rules to step by step we are through. Let Sn be the sum of the first n terms of an AP. Okay. S5 is equal to S9. What is the ratio of A3 is to A5? Beautiful question. It's a beautifully doable, very simple question. How do we do this? Let's say A1, A2, A3, A4, A5, A6, A7, A8, A9. This part, sum of all this is S5. This part, sum of all this is S9. Right. Nice and simple. Now, if S5 is equal to S9, what does that tell us? That tells us A6 plus A7 plus A8 plus A9 is 0. Add all four, we'll get 0. Nice. That means two of these should be positive, two of these should be negative, because they're symmetric expressions. So A7 plus something is A8. The same thing is A9. Minus something is this. So when you have an even number of terms in AP, then I can define this AP. It's very interesting, very important. I'm going to call a term in between this as A. I'm going to say common difference is 2D. Why 2D? But any time I have an AP, I love defining it in terms of a middle term. I don't have a middle term here because I have only 4 terms. So I'm going to define an imaginary middle term between A7 and A8, A7.5. I'm going to call that A. From that A, I move D this side, I'll get A8. I move D this side, I'll get A7. Or my common difference between A7 and A8 is 2D. Or I'm defining the terms as A plus D, A minus D, A minus 3D, A plus 3D. Nice, wonderful. A minus 3D, A minus D, A plus D, A plus 3D. I'm defining the AP like this. Now I know if I add all of this, I'll get 4A. Minus 3D plus 3D minus D plus D will all disappear. I love defining around middle term. I know 4A is 0 or A is 0. I'm through because now I know my terms are D, 3D, minus D, minus 3D. This is minus 3D. What will be this term? Minus 5D. I'm going to remove this S5 from here in order not to have confusion. This will be minus 7D, be minus 9D, minus 11D, minus 13D. I don't even have to find all this. I want to find A3 is to A5. A3 is to A5 is minus 9D is to minus 5D. Minus 9 is to minus 5, 9 is to 5. This answer, done. Anchor around middle term, you are waltzing through progressions. If it's AP, it is plus and minus. If it is GP, it is into and divided by. Wherever you don't have a middle term, have an imaginary middle term. I have A7 and A8, I will define the term A7.5, bang it between these two to be the middle term. And then I will move plus D this side, minus D this side. I am moving plus D and minus D, or difference between the two terms is 2D, good. Plus D minus D, plus 2D, minus 2D, minus 2D, done. Then we can define any number of terms, anchor around it, we are through. In a city, 50% of the population can speak in exactly one language among Hindi, English and Tamil. English is a very Indian thing, a very useful thing. English and Tanglish should be added to the lexicon. They make us super comfortable. While 40% of the population can speak in at least 2 of these 3 languages. Nice. Moreover, the number of people who cannot speak in any of these 3 languages is twice the number of people who can speak in all these 3 languages, which is nice. If 52% of the population, now this becomes too much. I cannot hold on to this much. So I'm going to put some numbers in. I'm going to draw this nice diagram, a Venn diagram in set theory. You must learn set theory. Hindi, English, Tamil. 50% of the population can speak in exactly one language. That is, this plus this plus this is 50%. It's very nice. While 40% of the population can speak in at least 2 of the 3 languages. That is, this is 2 and this is 40%. This is 50%. Inside here is 40. That means outside should be 10% to start with. Nice, so far so good. Moreover, the number of people who cannot speak in any of these languages is twice the number of people who can speak in all three languages. This 10% is twice the number that sits here, or this should be 5%. Lovely. What do we know? 40% of the population can speak in at least 2 of the 3 languages. So we say this is P, this is Q, this is R. P plus Q plus R is equal to 35%. Why? P plus Q plus R plus 5% is 40%. Remove that 5%, P plus Q plus R is 35%. That much we know. So far so good. Let's look at this. If 52% of the population can speak in Hindi and 25% of the population can speak in exactly in one language among English and Tamil, then the percentage of the population who can speak in Hindi, okay, let's accommodate this. 25% of the population can speak in one of, not both, exactly one of English or Tamil, which is brilliant. So we say this is A and B, A plus B is 25%. We know that the entire shaded region is 50%. That means the number of people speaking Hindi only, this number, let me erase this also because I want to fill in the data. This number should be 25%. Hindi totally is 52%. This number alone is 25%. Nice, because these two add up to 25%. Brilliant. Now we are getting somewhere because 25% plus 5% is 30%. So P plus Q should be the remaining of the 52%. We accounted for 30%. 25 plus 5 is 30%. So P plus Q should be equal to 52 minus 30, which is 22%. 22 plus 5, 27 plus 25, 52%. It will all add up, which is nice. Which means we can find R should be 13%. Number of people who speak English and Tamil only. English and Tamil without speaking Hindi. That is 13%. Nice. Then the percentage of the population who can speak in Hindi and in exactly one more language among English and Tamil. They can speak Hindi and in exactly one more language among English and Tamil. That is this territory and this territory. P plus Q, which is 22%, which is available and done. We're through. 22% can speak in Hindi and English or Hindi and Tamil. Not Hindi, English and Tamil. They're very clear. Exactly one more language. Not at least one more language. Nice question. For this we must learn some amount of set theory and get super comfortable with these Venn diagrams. Very important. Nice. A train left point A at noon, at 12 noon. 2 hours later, another train started from point A in the same direction. It overtook the first train at 8 p.m. That's very easy. Point A at noon. First train leaves. Second train leaves and they overtakes at 8 p.m. Or the first train has traveled for 8 hours. Second train has traveled only for 6 hours. It starts 2 hours late. 12 noon to 8 p.m. is 8 hours. Second train has traveled this in 6 hours. The ratio of their time taken is in the ratio 8:6 or 4:3. Or their speeds should be in the ratio 3:4. Nice. Time taken in the ratio 4:3, speeds are in the ratio 3:4. I can make that inference straight away. It is known that the sum of the speeds of the two trains is 140 kilometers per hour. Brilliant. Sum is 140, 3:4. 3 plus 4, 7 corresponds to 140. That means each number here is 20 or 60 kilometers per hour and 80 kilometers per hour. Then at what time would the second train overtake the first train? If instead the second train had started from point A in the same direction 5 hours after the first train, assume that both the trains travel at constant speed. So brilliant. Train A starts at 12 noon. Next train starts at 5 p.m. At 5 p.m. train A would have traveled 300 kilometers. Why 300 kilometers? Quite simple. because it travels at 60 kilometers per hour, 5 hours, 300 kilometers. So when the second train starts, it is 300 kilometers behind the first train, starting at 5 p.m. It has to catch up that 300 kilometers. In every hour, it catches up 20 kilometers. Why? In every hour, train A would travel 60, the second train would travel 80. The quicker train travels 80 kilometers, the slower one travels 60, or in every 1 hour, the quicker train gains 20 kilometers. It does 20 kilometers more than the faster. It has to gain 300 kilometers. How long will it take? Relative distance by relative speed, or 300 kilometers by 20 kilometers. 30 by 2, 15 hours. The 300 kilometers by 20 kilometers per hour. Or it will take 15 hours to catch up. Train A started at 12 noon. It will take 15 hours after 5 p.m. or from 12 noon, there's a total of 20 hours to go. From 12 noon to 12 midnight is 12 hours. So it will catch up at 8 a.m. Yeah, that choice is there. It will catch up at 8 a.m. exactly. Fine, nice. So it will catch up at 8 a.m. actually. 20 hours from the time the first train started, the slower train started. The train that was that left at 12 noon. The next in line, which is after the must do questions, the next in line. So common sense plus number theory. That's the part we're looking at. Let's attack this. The number of positive integers that divide 1890 into 130 into 170 that are not divisible by 45 is interesting. So all of these questions, prime factorize. And have a slogan for all our school kids: prime factorize or perish. So prime factorize. I don't like to look at 1890 into 130 into 170. What is sitting underneath that? How many 2s or how many 3s, how many 5s, how many 13s, how many 17s? Let's look at that. 1890 is 18 into 105. 90 is a multiple of 18, 18 is a multiple of 18. I divide by 18, I'll get 105. 130 is 13 into 10. 170 is 17 into 10. Nice. 18 is 2 into 3 square. 105 is 3 into 5 into 7. It is 5 into 21, 3 into 5 into 7. Into 13 into 2 into 5 into 17 into 2 into 5. A prime factorize this number. I have this number in my hand. I can enjoy and see how this works. Let me put everything together. There's a 2 here, a 2 here, a 2 here. I'll cancel all the 2's. I have 2 cube with me. A 3 square and a 3 and a 3 cube with me. A 5 and a 5. To 5 cube with me. A 7, a 13 and a 17. This is my number. I don't care much about 1890 into 130 into 170. This I like. Now any factor of this number has got to be of the form 2 power a into 3 power b into 5 power c into 7 power d into 13 power e into 17 power f. It cannot have 11 and a 23 as prime factors. So a can take value 0, 1, 2, 3. B can take value 0, 1, 2, 3. C can take value 0, 1, 2, 3. D can take value 0 or 1. E can be 0 or 1. F can be 0 or 1. Or the number of factors this number has is 3 plus 1 into 3 plus 1 into 3 plus 1 into 1 plus 1 into 1 plus 1 into 1 plus 1, or it is effectively 4 into 4 into 4 into 2 into 2 into 2. 4 into 4 into 4 into 2 into 2 into 2. 2 square, 2 square, 2 square, 2, 2, 2. This is 2 power 9. 2 power 9 is 8 cube, which is 512. 8 into 8 into 8. Beautiful. That's not what our question is asking for. Our question is saying how many of these numbers, factors, exist that are factors of this number but are not divisible by 45. What I'm going to say, hey, very interesting. I'm not going to worry about accommodating that 45 and finding factors that are not multiples of 45. From this 512, I'm going to subtract all numbers that are multiples of 45. 45 is 3 square into 5. I'm going to say, I'm looking at factors of this number that are also multiples of 45. From this 512, I'll subtract that and then I'm through. Right? So what do I have? I'm going to write down this number: 2 cube, 3 cube, 5 cube, 2 cube, 3 cube, 5 cube into 7 into 13 into 17. any factor of this number from 2 power A, 3 power B, 5 power C, 7 power D, 13 power E, 17 power F. We want a number to be a multiple of 3 square into 5. Or A can take value 0, 1, 2, 3. B, interestingly, can only take values 2 and 3 because 3 square has to be in the number. C can take only values 1, 2, 3. D can be 0 or 1. E can be 0 or 1. F can be 0 or 1. Or number of factors of this number that are multiples of 45 will be 4 into 2 into 3 into 2 into 2 into 2. 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 6 into 3, which is 64 into 3, 192. Brilliant. Now we have totally 512 factors of 45, of which 192 are multiples of 45. So how many are not divisible by 45? From this 512, I subtract this 192, or I have 320 factors of this giant number that are not divisible by 45. And so I find total number of factors and then subtract the number of factors of the number that do not happen to be multiples of 45. So that we subtract that. From total number of factors, we subtract factors that are multiples of 45 also to get the remaining number. Brilliant. To sum up to 10 terms of this series, 1 into 3, 5 into 7, 9 into 11. Very nice. 1 into 3 is 3, 5 into 7 is 35, 9 into 11 is 99, and so on. Now, very interestingly, this is A into A plus 2, 5 into 5 plus 2, 9 into 9 plus 2. I don't want to define like that. I want to define this number as 2 minus 1 into 2 plus 1. This number is 6 minus 1 into 6 plus 1, and so on, which is very useful because this is 2 square minus 1 plus 6 square minus 1 plus 10 square minus 1 plus 14 square minus 1, and so on. Up to what number? That's very interesting because we want 10 terms in this series. 2, 6, 10, 14. 2 is, I can write it as 4 minus 2, 8 minus 2, 12 minus 2, 16 minus 2, 4, 8, 12, 16. Last term will be 40 minus 2, 4 into 10 minus 2, or 38 square minus 1. 38 square minus 1 square, which is 1. 14 square minus 1 square, which is 14 square minus 1. So now we are effectively adding 2 square plus 6 square plus 10 square plus 14 square all the way till 38 square. And then subtracting 1, 1, 1, 1, 1, 1 10 times. So let's simplify it like that. We're basically saying let's do 2 square plus 6 square plus 10 square plus 14 square all the way till 38 square minus 10. What do we do now? Only 10 terms here. I'll extract a 2 square out, 4 outside, 1 square plus 3 square plus 5 square plus 7 square plus 9 square all the way till 19 square minus 10. I need to find a mechanism for finding this. I can write this as 1 square plus 2 square plus 3 square till 19 square and subtract 2 square plus 4 square plus 6 square till 18 square. Extract that 2 square plus 4 square till 18 square as 2 square into 1 square plus 2 square till 9 square. Subtract that and do it. Or I have a beautiful simpler method, especially because I know all these numbers. What are these numbers? 1 plus 9 plus 25 plus 49 plus 81. This side is 361, 289, 225, 169, 121. Add this whole thing up. That is this number. 9 plus 1, 10, 10, 25, 5, 2, 8, 16, 18, 24, 26, 6, 2, 5, 7, 9, 10, 11. Add this up. 10, 20, 25, 5, 2, 2 plus 2, 4, 8, 16, 165. 165 plus 1165 is 1330. A special number. 1330 is a very interesting number. So 4 into 1330 minus 10, which is 0, 2, 1, 5320 minus 10, which is 5310. Interesting question, not that easy, time consuming, but if you can reframe it, keep on reframing it, if you can think of n minus 1 into n plus 1 as n square minus 1, it becomes that much easier. You need 10 numbers, sometimes the beautiful algebraic, nice listing down formulaic method is interesting. This is expandable, scalable. This is far better. Just brute force it and get to the answer. It is given that the sequence xn satisfies x1 equal to 0. xn plus 1 is xn plus 1 plus 2 times root of 1 plus xn for n equal to 1, 2, 3. In all of these questions, find x1, x2, x3, see where it takes you. x1 is 0. x2 is 1 plus 1 plus 2 root 1 plus 0, which is 2 plus, x1 is 0, 0 plus 1 plus 2 root 1, which is 3. What is x3? x3 is x2, which is 3 plus 1 plus 2 root 1 plus 3, which is 4 plus 4, which is 8. Very interesting. x4 is 8 plus 1 plus 2 root 1 plus 8, which is 9 plus 2 into 3, 6, which is 15. It looks like each of these terms is an integer. I thought there will be a lot of irrational numbers coming in. Each of these is an integer. That means 1 plus xn is an integer. That means xn is square minus 1. If you think about this, this is 1 square minus 1, this is 2 square minus 1, this is 3 square minus 1, this is 4 square minus 1. Then 31st nth term is n square minus 1. 31st term, 31 square minus 1, which is 961 minus 1, which is 960. Nice. Write few numbers, see if there's a pattern. See, find the pattern, then we are through. What is the minimum number of weights which enable us to weigh any integer number of grams of gold from 1 to 100 on a standalone balance with 2 pints? Weights can be placed only on the left pan. The standard approach for this, you can do it with binary and several things, but the best approach is pick all powers of 2, starting from 1, 2, 4, 8, 16. If you had 5 weights, 1, 2, 4, 8, 16, we'll be able to think from 1 to 1 plus 2 plus 4 plus 8 plus 16, 1 plus 2 is 3 plus 4, 7, 15, 31. This will help us go from 1 to 31. Suppose we add 1, 2, 4, 8, 16, include 32, then we can go to 63. So 5 weights doesn't work, 6 weights doesn't work. 1, 2, 4, 8, 16, 32, 64. This takes us to weigh everything from 1 to 127. 6 ones don't work, 7 works. 7 is the answer. Why this should be powers of 2? Why are we thinking in terms of 1, 2, 4, 8, 16? It's too complicated to cover theoretically soundly. Right now, take it for granted. If you can place weights on only one side of the pan, think in terms of powers of 2. If you can place on both sides of the pan, think in terms of powers of 3. Because you can subtract also. If you can place only on one side, think in terms of powers of 2. That's it, done. 7 is the answer. Mark it, carry on. Next question. The unit digit in 743 par 85 minus 525 par 37 plus 987 par 96 is fine. So this is the unit digit will be same as 3 par 85 minus 5 par 37 plus 7 par 96. Unit digit. We need to worry only about unit digit. 3 par 1 unit digit is 3, 3 square is 9, 3 cube unit digit is 7, 3 par 4 is 1, 3 par 5 is back to 3. Unit digit of a number ending in 3, the powers will go in cycles of 3971, 3971, 3971. It's just cyclical, nothing more than that. And so 3 par 85. And so any power of any multiple of 4 will be here. 3 par 80 will be here. 3 par 84 will be here. 3 par 85 will be here. Same approach here. 5 par 1, 5 square, 5 cube, everything is going to end in 5. So this one ends in 5 straight away. 5 par 37 ends in 5. 7 par 96, 7 par 1 ends in 7, 7 square ends in 9, 7 cube ends in 3, 49 into 7, 343. 7 power 4 ends in 1, 7 power 5 back to 7. This goes as 7931, 7931, 7931 endlessly. 7 power 80 will be here, 7 power 96 will be here. This is 1. Or the units digit will be 3 minus 5 plus 1. 3 minus 5 plus 1. 3 minus 2 plus 1, which is minus 1, which is nothing but 9. Unit digit of minus 1. Or think of it as 13 minus 5 plus 1. 13 minus 5, 8 plus 1, 9. Unit digit is minus 1 or unit digit is 9. 0 to 9 is going in circles. If you have minus 1, that means you're adding a number ending in 3 to a number ending in 1. These two will add up to 4. Number ending in 4, you're subtracting a number ending in 5. 14 minus 5 is going to be 9. The answer is 9. Done. Right? Nice, simple, doable question. So what is the next one? The highest possible value of the ratio of a 4-digit number and the sum of its 4 digits. Very nice, very juicy question. Right, so suppose I'm taking 9999, it's a very large number. I have to divide this by 36. This is also a large number, 9999. So every time I put a large number, then my total also becomes very high. Sum of the digits. So I'm not looking to single-handedly put a large number there because I want to keep my total very small. So I want to create a number where maybe the leading digit is very high. The others all should be very small. Right? So, or maybe I'll put 000 as much as possible. I'll put this as 1. 1000 by 1 is 1000. Already I'm on fire. But I think it's very tough to better this because the denominator 1 is very powerful. If I have to put the denominator as 2, my number should become 2000. 2000 by 2 will also work. But can I do any better than 1000? Right? Now I look at the choices. The choices are 1000, 277, 900, 900. 1000 is possible. No choice is more than 1000. I have 1000 sitting in front of me. I don't have to worry about there being a possibility of some ratio being more than 1000. Because no choice is more than 1000. Done through. The can-dos. We're going to probably the counting territory. Let's attack this. The 5 parallel lines on a plane. 1, 2, 3, 4, 5. On the same plane, there are n other lines that are perpendicular to the 5 parallel lines. 1, 2, 3, 4, 5, 6. We don't know how many are there, which are all perpendicular to this. If the number of distinct rectangles formed by these lines is 360, what is the value of it? How do I find a rectangle? Rectangle is, this is the rectangle. This is the rectangle. This whole thing is a rectangle. The way to reimagine the rectangle, if I pick any two lines from here and any two lines from here, that will form a rectangle. Any combination of two parallel lines from here and two parallel lines from here is a rectangle. How do we select two parallel lines out of 5? 5C2. Two parallel lines out of n, nC2. 5C2 into nC2 is the maximum number of rectangles possible. 5C2 into nC2 is 360. Find n, we are through. 5C2 is 5 into 4 by 2, 10. 10 into nC2 is 360. Or nC2 is 36. N into n minus 1 by 2 is 36. N into n minus 1 is 72. So it's 9 into 8 or n is 9. Very simple. Two horizontal lines, any two out of the 5. Two vertical lines, any two out of the n. Combine them, we'll get a rectangle. Each of these rectangles is unique. All rectangles have to be found, can be found within this list. 5C2 into nC2 is an answer. Find n, we are through. Nice, juicy, simple, doable. The number of 5-digit numbers consisting of distinct digits that can be formed that only odd digits occur at odd places. It's very nice. 1, 2, 3, 4, 5. This should be odd. This should be odd. This should be odd. Mind you, they're not saying these two have to be even. They're only saying these should be odd. Odd 1, 3, 5, 7, 9. Luckily, it is 1, 3, 5, 7, 9. It had been even. Then here, the question had said odd portion should have even digits. Then I'm worrying because I should not have a 0 here. Out of 1, 3, 5, 7, 9, 1, 3, 5, 7, 9, 1, 3, 5, 7, 9, any 3 can sit here in any order. We can say 5C3 into 3 factorial, or we can say the number of ways of filling this is 5 into 4 into 3. 5 options here, 4 here, 3 here. Why 5, 4, 3? Because it says distinct digits. You cannot have the same thing. I cannot have a number which is 1, 4, 1, 6, 3. We cannot have two ones. So it is 5 into 4 into 3. 5 choices here, 4 here, 3 here. We have positioned the odd position digits. We've taken digits from 0 to 9 and positioned them. Right? Nice. We have put 3 places, 3 digits. So from 0 to 9, we have eliminated 3 digits, say 5, 3 and 9. These are out. How many digits are remaining? 7 digits are remaining. All 0, 2, 4, 6, 8 are remaining. And the 2 odd digits that have not been selected, they are remaining. Out of those 7, 1 has to go here, 1 more has to go here. 7 options for this, 6 options for this. Or total ways of doing this is 5 into 4 into 3 into 7 into 6. 5 into 4 into 3 for selecting the 3 odd digits and selecting and putting the 3 odd digits here. And then we have remaining 7 digits. Out of those remaining 7, the 2, they go into these 2 slots. The order is important, so not 7C2, it is 7 into 6. 5 into 4 into 3 is 60, 7 into 6 is 42, 60 into 42, 0 at the end, 6 is at 12, 2, 1, 25, 2, 5, 2, 0, which luckily enough is there in our choices. Done, through. The 10 points on a line, of which 5 points are collinear, and no 3 among the remaining are collinear. So we have 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. No 3 are collinear. Then the number of distinct straight lines that can be formed out of these 10 points. Brilliant. Distinct straight lines. And so we can have distinct straight lines defined by 2 points. You select 2 points, you can have a straight line. Now our 2 points can come from within this 5C2. Or can come from within this 5. These two, these two, these two, these two. But whichever way you select, there's only one line. These 5 points are collinear. Join any 2 points, the other 3 will sit on them. Only one straight line. The third way is to select one of these 5 points and combine with one of these 5 points. So you join these 2, that's a straight line. You join these 2, that's a straight line. You join these 2, that's a straight line. How many such straight lines are possible? 5 into 5, 25. Nice. 5C2 is 10. So the number of distinct straight lines that can be formed out of these 10 points is this 10 plus that 25 plus 1. 10 plus 25, 35 plus 1, 36. Don't forget this straight line. Brilliant. Let's go to the next one. The try to do's. So we've done the must do's, and then the next level, like you need to do to clear the cutoff, then can do, which is counting, and try to do. This is like juicier questions, but just give it a go any which way. If a function f of a is max of a comma 0, the smallest integer value of x, for which the equation f of x minus 3 plus 2 times f of x plus 1 equal to 8 holds true, is brilliant. First of all, f of a equal to max of a comma 0, or f of a equal to a if a is positive, f of a equal to 0 if a is negative. If a is 0, f of a is 0. That much we get. So f of x minus 3 plus 2 times f of x plus 1 equal to 8. Nice. Now x minus 3 and x plus 1 could both be positive. That is a possibility. Or this could be positive, this could be negative. That's a possibility. Or both could be negative. That's a possibility. Right? If both were negative, if x minus 3 and x plus 1 were negative, this will be 0, this will be 0. This is not possible. Both could be positive, in which case x minus 3 plus 2 times x plus 1 should be 8. X minus 3 plus 2x plus 2 should be 8. Or 3x minus 3 plus 2 is 3x minus 1 is 8 or 3x is 9, x is 3. So this goes to 0. That is 2 times f of 4, which is 8. That works. Or this is negative, that is positive. That means this goes to 0. 0 plus 2 times f of x plus 1 is 8. Or 2 times x plus 1 is 8. X plus 1 is 4. X is 3. In both cases it's only 3. If this goes conveniently to 0, the smallest integer value for which it is true is x equal to 3. That turns out to be the only integer value for which it is true. Both cannot be negative. If f minus 3 and x plus 1 were negative, this will go to 0. That's not possible. Both can be positive, or you can have this negative, this positive. X minus 3 negative, x plus 1 positive. X greater than minus 1, but less than 3 in between there. We don't have to worry about it. In both scenarios, the answer is 3. Done. Doable. Just poke around, we can do this. Suppose that a real valued function f of x of real number, f of x plus xy is f of x plus f of xy for all real x and y, and that f of 2020 is 1. Compute f of 2021. Seems like an incredibly tough question, fine. But we need to keep in mind that all of this is just algebraic guff to intimidate us. I'm going to simplify that. I'm going to say, hey, all interesting, but I don't want x, y and all. I'm going to put y equal to 1. F of x plus x is f of x plus f of x, or f of 2x equal to 2 times f of x. F of x plus 2x is f of x plus f of 2x if you put y equal to 2, or f of 3x is 3 times f of x, because f of 2x is 2 times f of x. 2 times f of x plus f of x, 3 times f of x. F of 4x is 4 times f of x. F of 5x is 5 times f of x, and so on. And nice, so far so good. Very interesting. So we've got this far, and we know f of 2020 is 1, or f of 2020 is 2020 times f of 1. Nice. So if we can find f of 20, we can find f of 1. What is f of 1? 1 by 2020. What is f of 2021? This is 2021 times f of 1, or 2021 times 1 by 2020, or the answer we are looking for is 2021 by 2020, which is there. Done. Lovely. So it looks like f of x plus xy is f of x plus f of xy. Plug in y equal to 1, or plug in y equal to 0. Y equal to 0 doesn't work, therefore 1. Then go step by step, figure it out, simplify. In all of these questions, putting x equal to minus 1, y equal to 1, put x equal to y, put x equal to y equal to minus x, x equal to minus y. One of those will open it up, and then we are through. The angles of a triangle ABC are in arithmetic progression such that sine of 2a plus b is half, then sine of b plus 2c is equal to something like there is trigonometry, the sine, and then there is progression. Seems like impossibly tough. They are an arithmetic progression. That means a, b, c, b minus a equal to c minus b, or I can define this as b minus common difference, b, b plus common difference. I add all of this. This is 3b, which is 180 degrees. Why? Sum of the angles in a triangle is 180. Or if 3 angles in a triangle are in arithmetic progression, the middle angle is 60 degrees. I've already got that. So my angles are not a, b and c. It is a, 60 degrees, and c. Sine of 2a plus b is half. Sine 30 is half. That I know. And so half should be sine 30. That's not possible. 2a plus b is not 30. B is 60. Or sine 150. I know sine theta is sine of 180 minus theta. So sine 150 is half, or 2a plus b is 150 degrees. I I know B is 60, so 2A is 90 degrees or A is 45 degrees. I'm done because I know A is 45 degrees, B is 60 degrees, C is 75 degrees. 60 minus 15, 60 plus 15. Sine of B plus 2C is sine of 60 plus 2 into 75. This is 150, which is sine of 210 degrees, which is sine of 180 plus 30, which is minus sine 30. Sine of 180 plus theta is minus sine theta. It will be in terms of sine. It's in the third quadrant, negative, minus sine 30, minus sine 30. Sine 30 is half. This is minus half. Done. Seems like an intimidatingly tough question. There's progression, there's trigonometry. 3 terms are given in progression. Sum of those 3 terms is 3 times the middle term. Or these 3 angles are in AP. The middle angle is 60. One of the 3 is 60. If we know angle B is 60, we know 2A plus B cannot be 30 degrees. So 2A plus B has to be 150 degrees. We're done. 45, 60, 75. We still need to know how to find sine 150, how to find sine 210. That you should know, you must know. But if you know that, then this becomes more straightforward. The x-intercept of the line that passes through the intersection of the lines x plus 2y equal to 4 and 2x plus 3y equal to 6 and is perpendicular to the line 3x minus y equal to 2 is. We have a line that's perpendicular to 3x minus y equal to 2. Perpendicular to it should be of the form x plus 3y equal to k. We're looking for an answer like this. We want to find k. That's it. Now this line passes through the point of intersection of these two. Solve that, we are through. X plus 2y equal to 4. 2x plus 3y equal to 6. Multiply this by 2. 2x plus 4y is 8. Subtract this 2x plus 3y equal to 6 from that, y equal to 2. X plus 2y is 4. 2 into 2 is 4 or x is 0. The point of intersection is 0, 2. X plus 3y equal to k passes through 0, 2. Put x is 0. Put y is 2. K should be 6. Or our equation, the line we are looking for, is of the form x plus 3y equal to 6. What do we want to find? We want to find the x-intercept of this line. When x-intercept of the line that passes through the point of intersection of these two and is perpendicular to this. This is the equation of the line. How do you find x-intercept? Put y equal to 0. X-intercept is equal to 6. Done. It is there. Done. Only if you have time. I don't have time, so I'm going to stop this. There's a route to getting to 20 questions very well, very juicily in a reasonable time frame. If you attack them, we have not touched on LRDA, which is a very juicy set. You can attempt that and nail that very comprehensively. And this only if you have the time. I don't want to do this now. So even if you didn't have the time, you have a wonderful way of cracking this paper if you keep your wits with you. But you must have the ability to pick and choose the right questions. Do the must do, your sweet spot question. Then move to a little bit of number theory, set theory, permutation, combination. Do the juicy few. Don't touch the ones with functions, trigonometry, coordinate geometry, heavy duty geometry. Keep them aside. Where x and xy and x cubes come, keep them aside. Maybe 1 or 2 of them are easy. We will come to that if you have the time, but otherwise don't touch them. With some a good mix of delicious question selection and keeping your wits with you, you can clear the quant section. And if you have the gear to approach these trigonometry functions questions, if you have the ability to not be intimidated by 3 sine square x plus 12 cos x, then you must say, I will have a go at that also. But having a go at that must come after you put all these juicy ones in the bag. You cannot say, look, I'm the doyen of trigonometry, go and attack that and get and not get value for time spent. Super important to know your home territory, get that, put it in the bag, then say, okay, now I'm going to go for my advantage, I'm going to go for the kill, I'm going to go for going ballistic and taking my score to one super high level. That should be your approach. Get the easy ones in the bag, then go for the kill. Wonderful folks, best wishes.